Okay, so number 3 on quiz number 3. Draw a resonance structure and provide a formal charge. So I was really disappointed by this. Not that you guys owe it to me to give me life satisfaction, but 9 people in the class got full credit on this one. And this one really, at this point, you should be able to do this falling off a log. So I can tell you, if you're wondering what you should do, there's a resonance structure practice set on Wiley. Looks like maybe 3 people have done a couple of problems on them. That's not due. You don't have to do it. You don't have to do resonance practice. But what you have to do is be able to draw resonance structures, okay? This will be a huge part of exam 1. It will be a huge part of reactions we do. And so you really need to get this down. Okay, with that, I'm going to walk through this. There's a couple of really good ones. First of all, let's put formal charges in. Well, it's a line structure, so I'm not putting it, it's not a full Lewis structure. 2 hydrogens there, hydrogen there, hydrogen there. You've got 1 atom, right? Nitrogen with 4 bonds is positive. Oxygen with 3 bonds, positive. Okay, so the net charge +1. So your resonance structure, whatever you draw, has to have a +1 charge. All right? No change in charge. No change in connectivity. Okay, so you can't just move electrons around randomly. You can only move pi electrons around. You can't break any sigma bonds. So let's look at the answers, and then I'll go through some of the incorrect answers. You can write this down. I'm going to do some erasing first. So again, nitrogen with 4 bonds. That's the charge. Your net charge is +1. Any resonance structure okay? Any resonance structure you draw has to be +1. Quite a few of you, I said 9 people in the class got full credit. Quite a few people drew a structure, drew the proper resonance structure and just didn't put a charge in or got this charge wrong. So that was a lot of mistake. Okay, so first thing we could do is just move the electrons there. That puts a lone pair there and is going to leave a positive charge there, right? Electrons go away from a neutral atom. That leaves the resulting atom positive. We could also move those electrons there. Sorry. Okay, +1 charge on the whole structure, +1 charge on the whole structure. Same connectivity. All right, that's an sp2. Let's put hydrogens in. I don't know if you guys did this explicitly. Right, so H, 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 CH3, CH3. All right, there's 1 hydrogen on that carbon. Well, down here, so there was a plus there. Okay, so 1 hydrogen on this carbon, 1 hydrogen on that carbon here, 1 hydrogen on this carbon here, 1 hydrogen on that carbon there. We can do this over here again. Okay, these methyls, that carbon has 4 bonds to it, 4 sigma bonds. These 2 methyl groups cannot be involved in a resonance structure in any way. So quite a few people drew, so these are correct. Okay, so I saw, what are some of the other ones I saw? Okay, well, if there's no charge on this carbon, that carbon's got to have 4 bonds. That means there's 2 hydrogens here. All right, that carbon only has 1 hydrogen. So by putting 2 hydrogens there, you've changed the connectivity and it's not a resonance structure. Likewise, this carbon has 3 hydrogens. That carbon, if there's no charge, has 2. Okay, so effectively you've moved a hydrogen from this methyl to that carbon. That's a chemical reaction that can take place, okay? So I'm not telling you that chemical reaction can't take place. It's a reaction. You're breaking bonds. Those aren't the same structures. A lot of you are going to see on your quiz, I'll write this, 5 bonds. Okay? If you see me having written 5 bonds, what that means is by drawing a double bond here, that's a CH3. If the connectivity is the same, then if that's a CH3, the 3 hydrogens are 3 bonds, the double bond is 2 bonds, that's 5 bonds. You've got a tetravalent carbon. The other thing is, if you do that by moving electrons, that really should get a positive. For this to have 1 hydrogen, right? For that to have 1 hydrogen, that should be a positive charge. Now you've got multiple charges. So that's one way it was incorrect. I saw some, what was the other one? Saw some of that. That'll get you a 5 bond indicator, right? If I make a pi bond there, there's a hydrogen there. There's a hydrogen on that carbon in the real structure. So if that hydrogen is still there, that's 5 bonds. Likewise, there should be a charge here. In a lot of cases, people simply miss the formal charge. So there were many more kinds of wrong answers. Simply getting the formal charge wrong was an error. Not having, a lot of people showed me there was a positive here. Let me do that one. I think quite a few people did this. Okay, so what's wrong with that? Why is this not a correct resonance structure? Well, the reason is your connectivity is actually identical. Okay, so there's 2 hydrogens here, there's a hydrogen there, CH3, CH3. Connectivity is fine. But you've got a negative charge. This structure up here is positive. You've actually added 2 electrons to the molecule. And again, you can do that. That's a chemical reaction. We could take this molecule, we could add 2 electrons, we'd get this molecule. But it's not a resonance structure. They're not the same structure. And there were versions of this where people moved the charge. A couple of people just turned it around. So all right, that's just the same structure. That and that. You just pick one up, flip it over, and they're superimposable. They're the same structure. The same structure is not a resonance structure. A resonance structure, you have to move some electrons around. So again, to draw a resonance structure, you want to move electrons. Connectivity, the sigma bond network has to stay the same, and the overall charge has to stay the same. Okay, so if you're not getting this, before exam 1, there's a big Wiley Plus resonance problem set that you can practice. There is no due date. I'm not going to give you points for practicing it. What I'm going to do is let you practice it so that, on number 3, which is a 40-point resonance question on exam 1, you don't miss it. Okay, so get this stuff down.